All right, hope everybody's doing well today. So today's experiment is on extraction techniques, and so what we're going to be doing is three different parts. So the first three parts are going to be extraction of caffeine, identifying the distribution coefficient, and then also identifying the organic layer. And so for the first part, we're going to be extracting caffeine. And so what we want to do is get a centrifuge tube. So we've got our two caps. And what we want to do is make sure that they don't leak before we use them. And so we're just going to take the cap off, squirt a little water in here. Okay. And then go ahead and cap it, and then we will see if it leaks. So it's better to see if it leaks with water than it is to kind of just use it and then find out later that it leaks and have methylene chloride leaking, because methylene chloride is really volatile. It's carcinogenic, and it's mutagen, and so it's just a nasty substance that we don't really want to just have pouring out of the centrifuge tube. And so this guy seems to be working pretty well, so that's awesome. I will check this one as well just to see if we've got two perfectly good centrifuge tubes. The cap's really hard to get off, so it's likely that they're good, but boom, little water in there, cap that, and doesn't seem to be any leakage. So what we want to do now is weigh out 0.070 grams of caffeine, and then we're going to dissolve it in about 4 ounces or 4 mils of water. So let's go to the scale and we'll weigh out that the caffeine. Okay, so now we're about to weigh out the caffeine, but I just wanted to show you the scale first, and so we'll take a look at that. All right, so here's the scale, and next to the scale you'll typically find the reagents that we need to weigh out. So we've got our caffeine here, and it's, as you can see, the caffeine has a harmful warning on there. Obviously we consume this regularly, but very unsafe in its pure form. If you could potentially overdose. And so this is our weigh paper, and then this guy is to clean up any spills that we might make when we're weighing out our solid. Okay, and so what we want to do is hit that on/off button to turn the scale on. Just give it a second. As you can see, there's on the side of some of these scales we got a little window or roof that kind of slides on that one. On the side, we have little doors that open as well on both sides. So we got that one as well. So now what we want to do is get some paper on there, weigh paper. Now you can see that it registers a mass, right? We don't necessarily want to gather that mass because we just want the 0.070 grams of caffeine, right? So what we can do is press this to tare it or zero it out, and it doesn't take the mass of the paper anymore, and it sets it to 0. So now anything that we add that's caffeine is going to register only that. Okay, so let's get the mass of the caffeine right now. Okay, so just for the camera angle, you know, we're in isolation. I'm doing this by myself, so got to do what we got to do. Got my weigh paper, right? So what I suggest that you guys do when you're weighing things to make basically minimize spills and allow for easier delivery of the solid material to whatever vessel you're putting it in, you take that weigh paper, you fold it in half, okay, boom, and then you fold it in half again, okay? So what this allows to create is kind of like a little area where the solid can collect, and then when you're ready to pour it, it just kind of sits like that, and then you can easily pour it out, okay? And so let's go ahead and put this on here. We'll close all of our windows. I'm going to zero that or tare it. Okay, and so now any caffeine that I add, that's how much we have on the scale. Okay, so I'm going to put both arms through on either side just to minimize the amount of spill that I have. I don't want to have any loss of caffeine, just in terms of like saving the chemical, but also I don't want to have to clean up. I don't want to make a mess. So this is way too much. I only need 0.070. Okay. And all right, so there we go. And it doesn't have to be perfect. So most often you don't have to get exactly whatever your mass is. You just really need to record the exact mass that you've obtained. Okay, so it does need to be close for for uh, for a lot of reasons, but just try your best. Don't spend 5 minutes trying to get exactly 0.070 though. So if it's 0.071 or whatever, or it's even like 0.075 or 6, 7, 8, it's fine. It's not that much of a difference, and to save time, you just kind of move quickly and get it on there, and then record what you actually have. Okay, so there we go. All right, so now that we've got our approximately 0.070 grams, I ended up going with actually 0.08 just because I can. And now what we want to do is place that inside of the centrifuge tube. And remember, I folded this nicely so it's got that V shape, so I can easily just kind of tilt it and pour that in there. Now, if you do spill any, depending on the experiment that you're doing, you would probably have to start over. So you want to be really careful when you do this. And I don't really have any on here anymore, so we are good. Now, we do need to add 4 mils of water to that. So what we're going to use is our graduated cylinder. I got the 10 mil one here. And I can just, this is clean deionized water, so I'm going to go ahead and squirt that in there. And you see? Now, remember when you're reading the where the level of the water is in any kind of vessel, you want to kind of get at eye level and check out the meniscus, right? So you'll just have to take my word for it when I do this. Boom. It's good. So let's go ahead and pour that inside of the centrifuge tube. All right, so we're going to go ahead and cap this. And then we'll shake it until it dissolves. You want it to dissolve completely before we add the methylene chloride. Okay? So this might take a minute. You don't want to see me shake, shake, shake. So, to be continued. Meanwhile, still going. You can still see it in there. Whatever you gotta do. Might as well have fun while you're doing it, right? Also make sure it's not leaking. All right, so finally got it all dissolved. So let's check out the hood. I'll introduce a couple features of it that you need to be aware of, okay? All right, just to show you a hood from far away. That's the hood. We've got that one, this lone one right here that's white, and then another orange one. So here we go. Here's some chemicals. We got our methylene chloride for the next step of the extraction. You see this guy right down here? That top button turns the hood on, the bottom button turns it off. You want to make sure whenever you're working in the hood, it's always on. And then I just put this one in here just to show you guys. We've got a waste jar here. So this is what our waste is going to look like. It's going to be likely a beaker inside of a secondary containment. So another container in case anything happens, like that glass breaks and it has to, we have the liquid that might be inside of here gets captured inside of this secondary containment, and we don't have a huge mess, hazardous mess. And then, yeah, so it also, anytime you're throwing something in that waste, you want to make sure that it's very specific, and it says, for example, experiment 1, and then what's the date that we're running this, or the halogenated and unhalogenated waste. We want to make sure that whatever you're throwing in there has that, whatever we want to make sure whatever you're throwing in here is on the list of chemicals that's on this waste label. Okay, if it's not on here, you need to come to me immediately because you shouldn't put it in there. There's probably another waste container there. Okay, it also has some warnings on there. So we've got a cancer hazard and environmental hazard. So the chemicals that we're using for this lab are pretty gnarly. That's pretty much the case for organic chemistry, though. So that's why safety is my main goal here. Now, on that note of safety, well, first there's a light switch, right? What do light switches do? They turn on lights. Okay, so that's what's going to happen here. Oh, light on, light off. But see this arrow right here? This arrow is where you can, the highest point that you can bring this sash. The sash is basically the window of this hood. So you can have it all the way down. It's fine. It's actually working at its safest if it's all the way down. But the maximum height is that arrow, and that's 18 inches. You also want to be working about 6 inches back from the start of the hood. Okay, so from here, work 6 inches back, and that's going to provide the optimal airflow to keep those vapors inside of the hood and not in our face. Okay. Hi. All right. So now what we want to do is work with the methylene chloride. So this is the stock bottle. Now remember, we don't want to put or dip into the stock bottle. What we want to do is typically next to the stock bottle will be a smaller container, and it's also labeled methylene chloride. Now, what you want to do is uncap this, pour that into that smaller container here, because if we were to contaminate this, that's a much smaller volume, less chemicals that we've kind of ruined than if we were to contaminate the stock bottle. So basically, I've already poured the methylene chloride into this smaller portion, and now what we want to do is set aside 2 mils for the extraction. Okay, and what I'm going to do is weigh or measure out about 2 mils inside of my graduated cylinder. Okay, now if you were exact, then you could just take this and pour that right into the centrifuge tube, but that's not quite exact. So what you can use is a pipette, and so we have this. Remember, this latex rubber bulb and a glass pipette, and you can squeeze it and put it inside of the liquid. Now, when you release, you can see the liquid kind of coming up here, right? Now, the methylene chloride has a tendency to jump out of pipettes when you move them around. You can see that it's dripping here. It's got a high vapor pressure. It's really dense. And so you have to be really careful when you're working with it because you don't want to drip it on you, right? So you can either have it really close to minimize the distance that you have to travel with the pipette, so therefore minimizing the amount of dripping on the benchtop or whatever. Or you can also hold it with one hand to put them right next to each other. And so that's what I'm going to do. I'm going to just lift this up. It's dripping at somewhat of a constant rate. And so once it drips, I move. And then I squeeze the pipette bulb to squirt that inside of the centrifuge tube. Okay? And then I can do it again. So squeeze, let go. See it kind of going up. And you can see it's actually not squirting down yet. And so now is the time to move. Okay? And there you go. Now I've transferred my 2 mils. So now what I want to do is cap the centrifuge tube. And I'm going to want to invert this a few times. It's basically shaking. So I don't want to shake too vigorously because what's going to form is an emulsion. And that emulsion takes time to kind of go away and separate into the 2 layers that the methylene chloride and the water usually do. And so it's like oil and water. You can kind of see the 2 layers. So one of them is right there. See that? And then the other is up here. So that's just like oil and water. And so it's really important for you to write down your physical properties in your laboratory notebook so that way you know where methylene chloride should be and where water should be. Methylene chloride is really dense, much more dense than water. So it's also going to, we might assume that it's going to be at the bottom. So you also want to make sure that you're aware of the solutes being dissolved in the solutions as well, because remember, dissolving, like, for example, salt water. Salt water is more dense than just pure water. And so the more solutes you have dissolved in a given liquid, the more dense it becomes. And so if it were close, this might be an issue. But we also know that we had 4 mils of water, right? And we had only 2 mils of methylene chloride. So this is a little trick for you, okay? So you can kind of see which volume is greater. So there's one portion and there's a smaller portion. That smaller portion is on the bottom. That kind of goes along the lines of where methylene chloride is, right? Another thing you can do is you can actually look, if it's possible. Let's try it. So if you can observe where that drop of methylene chloride goes, then you can kind of be more confident as to which one is which in terms of the layers. So in a centrifuge tube, it's very difficult to see because it's more opaque, but if you were working with a glass normal test tube, then it would be much easier to see. And so we can test that later to see if we've got the proper layer, okay? So I'm going to go ahead and let that hang out for a while we wait for the 2 layers to separate. Okay, so just to observe what an emulsion looks like, what I want to do is shake this up for you and to create an emulsion, and then I'll pour it into a glass test tube, and then you get to kind of see what an emulsion is and what I mean by that. And so you'll also see more or less how quickly it does not separate into 2 layers. So here we go. I put a little paper towel around here just as a secondary backup for if the lid were to fail or if there's any leakage. I don't want any on, because these gloves are not necessarily perfect. Even chemicals can go through them. It's just gives us more time to take off the glove and protect ourselves. So, all right. So now that we've got that, let's go ahead and take a look. What I'm going to do is pour this. You can kind of see it looks a little bit more creamy. I'll pour this into that glass test tube right there. Just so we can kind of observe that. See that? There's 2 layers. It's very clear, but these 2 layers should actually be colorless. And so this has got a white kind of color to it. And what that is really just a bunch of small bubbles. And it's going to take a minute for these guys to separate. But one thing that we can do to make this happen faster is pour this back into the centrifuge tube and then put it into the centrifuge. And we also have to remember to balance the weight on both sides. And so I'm going to go ahead and do that with another centrifuge tube, which I have. Okay. So let's go ahead, and you can kind of see that it's maybe clearing up a little bit, right? So if we get a little impatient, we can go that centrifuge route. But maybe we'll just wait a couple minutes, see kind of how it goes. Okay. Okay, so I'm too impatient. I'm not about to wait for the emulsion to go away without the centrifuge. So what we're about to do is weigh real quick how much the centrifuge weighs with the methylene chloride, the caffeine, and the water in there. And so what we're going to do is put a beaker on the scale, tear that, and then place the centrifuge inside of the beaker to see how much it weighs. Okay. All right, so we teared that. Now we get this guy. See how much it weighs. See, this is the one with the caffeine and all that goodness. Caffeine in all of its glory. 15.242 grams. So what we want to do is just try our best to get as close to that as possible. And what we're going to do now is place this guy in here. And I'm going to throw the cap on the side. Okay, so that's 9. We need about 15, right? So let's open this bad boy open. Use the squirt bottle, squirt a little water in there very carefully. You should probably take this out. Let's go ahead and take this out so we don't squirt water onto the scale, huh? And then we'll just go ahead and weigh that. Ooh, so close. And oh, way off. So basically, you get the idea. I'm going to go ahead and correct that, and then we'll be good to go on the centrifuge. Okay, this is 16. So that's about a mil of water too much. So I'm going to take a mil out approximately and get it down to 15.2-ish. And then I'll show you how to work the centrifuge. All right, here's our centrifuge. And this little guy right here will open it up for you. And I already went ahead and put my 2 centrifuge tubes in there. So you want to make sure that when you're doing this in the classroom, it's not just you, right? So you want to make sure that your centrifuge is labeled, or whatever you're putting in here is very well labeled. And you also want to make sure it's balanced. So as you can see, I have this tube, which is the same mass as that tube approximately, and they're opposite of one another. And that's going to help it keep balance. So as it spins, it won't spin out of control. So, all right, now I can close this. I'll leave this in here for a couple minutes, and then we'll just take a look to see if the emulsion has improved, okay? So basically just turn that, and then we'll be done in a couple minutes. All right, so let's see if, it's been a couple minutes, so let's see if that emulsion is separated. So I don't remember if I had it in 1 or 3, but it looks pretty good. Separated. No, there's clearly 2 layers there, and I don't see any an emulsion. So I'm gonna go ahead and put that down so we can turn this camera off. All right, so now that we've got our emulsion separated, we got to clear 2 layers of methylene chloride on the bottom and water on the top. We're going to go ahead and transfer it to this lovely clean test tube. And remember, well, obviously, you got to take that cap off. Okay, so I'm going to hold it with one hand, so that way they're side by side, very close to one another. And I'm going to use my pipette and bulb to transfer the 2 liquids. So as I do this, what I'm going to do is squeeze out, and you can kind of see the bubbles maybe. You're going to want to get in only the bottom layer though, right? So it's really hard to do when you're working with a centrifuge tube that's kind of opaque. But that's okay. If you get a little bit of water in there, we can separate that too. Okay, so just because It's hard for me to see at this angle. I'm going to go ahead and call that done. What I can do also is just add a little couple drops back to the centrifuge tube, and then you see it dripping, drop. Now I move over, and I didn't spill any, so now I can squeeze that into the glass test tube, and it looks nice and clear, right? There's no two layers there. This is just kind of the way the glass. It kind of looked like it. Oh, right there. It kind of looks like there might be two layers, but that's just a reflection. So there you go. That's how you would transfer the methylene chloride layer into a clean test tube. All right, so now since we've got our first extraction taken care of, we've got the methylene chloride and the 2 mils in there. We're going to go ahead and add another 2 mils to our original centrifuge tube. Okay, so this is the centrifuge tube that had we added 2 mils of methylene chloride with the 4 mils of water and the 0.07, or I weighed out about 0.08 grams of caffeine, right? So we took 2 mils of methylene chloride we had in there, and then we placed it in here, right? So now this is just the water that was left behind. I'm going to go ahead and add 2 more mils of methylene chloride to that, because what we're assuming is we didn't get all of the caffeine out on that first extraction. And that's 100% true. We got a lot of it out, but not all of it. And so we want to make sure we get all of it out. So what we're going to do is we're going to do this a total of 3 times. Okay? And so now I'm putting the paper towel on there, and I'm going to invert that a few times. Okay? And we're going to do this for about a minute, and then let the 2 layers separate again, and then we'll transfer the 2 mils, about 2 mils of methylene chloride into the same test tube as the original 2 mils of methylene chloride, okay? So we're combining all of our organic layers, which are the methylene chloride layers. We're combining all of those into one pot or one test tube, because in the end, what we should have is about 6 mils of methylene chloride, and ideally most of that caffeine that I put in the water initially, which was about 0.08. Okay? So now let's take a look. We don't have any leakage, so that's good. You can see that there's like a little bubble right here, not too bad. We can just let that hang out for a second, okay? And then we'll go ahead and transfer that liquid. And we're back. Okay, so we've got, actually that's not a break for you guys. We're just cutting straight to it. That was a little break while we let this settle. We've got nice clear 2 layers, and so we're going to hold these 2 bad boys together like that. We are going to transfer the organic layer, squeezing the bulb, now placing inside of the liquid. I don't want to create too much of a disturbance is why I'm doing it like this. So if I go in there and then squeeze it, all the bubbles might kind of mess things up for me. And so now I'm slowly releasing the bulb on the top, because I don't want to take necessarily all the methylene chloride on the bottom, because I don't know if that's going to completely fill the pipette or what. And so now that we're done, drip, 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 drip. Now I'm transferring. Boom. Okay. So we do have a little bit more in here. So I'm going to, now this time I'm only squeezing the bulb like probably halfway down as I go down. And now I'm only going to get some of that methylene chloride on the bottom. And that's the key to collecting just the rest of the liquid that's in there. You can kind of see there's 2 layers in there now in the pipette maybe. And so what I'm going to do, you see that? Oh, Oh, you can see it go down, down, down. I'm gonna squeeze that out because that was water trying to make his way in there. Get out of here, water. I don't want you. I do want you, actually. I'm thirsty, but I don't want you in my methylene chloride layer. So there it goes. I did that transfer. Nice and clean. Now, what we're going to do is one more extraction. But as I place this pipette down carefully, I want to remind you that you never want this pipette to be upside down. Because if it's upside down, the residual methylene chloride in here is going to climb inside of this, and it's going to ruin it. So you can, if you don't trust yourself, just separate it, okay? And then have it sitting there. That way no chemicals get inside of it and it doesn't get sticky, because eventually what's going to happen is it's going to get sticky and you're going to squeeze it and it's not going to open back up. And that's a useless pipette and you're going to have to get a new one. Or you're going to not know you're going to need a new one and you're going to just struggle with it for a long time and get frustrated with chemistry lab. And it's not chemistry's fault. I'm not going to lie, it's your fault. Because I told you, write me out. All right, so let's go ahead and get that 2 mils. Ooh, that's perfecto. So I'm gonna go ahead, pour that in here. Remember, this is the original centrifuge with the caffeine supposedly in that water, okay? Now, what we're gonna do is cap that, give it some inversions for about a minute, and then let the 2 layers settle, okay? Bye. Okay, so it's really important. I don't like putting my hand on the bed. It's really important to read through your laboratory procedure before you come in here, because you want to get an idea as to what you're doing before you actually do it, okay? For example, we are doing an extraction today, and then after those extractions, what we're doing is we're boiling down the methylene chloride that we've obtained. And how are we doing that? Well, we're doing it in a hot water bath, right? Well, hot water kind of takes a while to heat up, and so you want to set something up before you actually need it, if possible. For example, a hot water bath. So what I mean is, let's get some hot water or some water in here. It's about to splash all over me. All right, so we've got that water in our little crystallization dish. This is typically what we use for a hot water bath. Now what we're going to do is we're going to put it on a hot plate, turn the heat on, and walk away from it, checking on it periodically throughout the experiment. And then when it comes time to need that hot water to boil off our methylene chloride, we've already got it, and it's been heating up while we were working. And rather than getting your methylene chloride layer, and you're like, oh crap, I need a hot water bath. Well, let me set that up and then sit around for like 10 minutes while it heats up to temperature. So that's a waste of 10 minutes, right? If we just do it now, we got it working while we're working, and then boom, boom, bang, you're in and out of lab. You got better things to do, like study chemistry, write that lab report. More than likely, you got other classes, job, life, etc. So we want to work as efficiently as possible in the laboratory, and this is one way to do it. And the way we would have known this is by reading ahead. Okay. All right, so we've got this hot water bath on a hot plate inside of a hood, okay? And so it's plugged in, and you know it's on because we got that green light, okay? So notice the heat and stir are options. Like the stir doesn't even need to be on, but the heat does. So let's put that to about 4, and then you'll notice that when it's hot, that orange light will turn on, and that's how we know we've got a hot plate. And so you want to make sure that you're really careful when you touch it or when you're working with it. And so now that we've got this set up, I'm about to turn it up actually. we want to keep an eye on it throughout the experiment, but it'll be nice and hot when we're ready to use it and boil off that methylene chloride. All right, so we are good to go on that last separation. And one thing that I noticed that I think that you guys would be wondering about is my pipette. It's got a little, you can't really super see it. Oh, there we go. See that little white crusties on the bottom? What is that? What do you think it is? I'll let you think about it. And then maybe I'll remember to tell you at the end. But it's not bad. Okay? So, here we go. Remember, holding these with one hand, side by side. So that way, when I'm transferring the methylene chloride, I don't have to travel a far distance, and I can minimize the spillage. Squeezing the pipette tip, get in there, extracting the methylene chloride, or get that sucked up into the pipette, and go ahead, boom. So that might have been all of the methylene chloride. The way we can check is suck that into here. We've got maybe 2 layers. It's hard to tell. Again, it's kind of difficult looking at the 2 layers of water and methylene chloride inside of an opaque tube. So what you can do is transfer, especially on that last one, you want to make sure you get everything. You can transfer that, carefully pour it into a glass tube, one that's more easily seen through. And it looks like we don't really have, we might have a tiny, tiny bubble at the bottom, like so tiny you can't even see it. I can see it, but I'll tell you what, not worth trying to get, because what's going to happen is I'm probably going to introduce more methylene or more water into this than I would want, which is any introduction of water I don't want. And there's really not that much caffeine left in there, because after one extraction we get a majority of the caffeine, and then after the second extraction we get even more of it, and then the third extraction, it's just good for good measure. And you'll see when you do the distribution coefficient and calculations, and you'll see how 1, 2, 3 extractions gets a different percentage of the solute, and you'll agree with me in that it's not worth it trying to get that last little bit. So now that we've got this is all of our methylene chloride. Now, just during that process, we are going to get a little bit of water in there. We don't want water in there, and so what we're going to do is we're going to add a drying agent. So there could be a variety of drying agents that we work with in the lab, but the most common one is sodium sulfate. Okay, so let's check it out. Okay, so sodium sulfate, Na2SO4, not to be confused with sodium sulfite, which is the SO3, and this says anhydrous. Okay, so it also says replace the cap. Replace the cap immediately, because when you take it off, especially in Santa Barbara, there's all kinds of water in the air. You want to make sure that you put that cap back on when you're done using it, because water from the atmosphere can be absorbed into this sodium sulfate, because that's what it does. That's its job, right? It dries things, and it is a hygroscopic substance and absorbs water from the atmosphere. If it does that, if it absorbs from the atmosphere, it's going to get all clumpy. I went ahead, and it's going to be useless at that point, right? It's not going to, if it's absorbed water from the atmosphere, how's it going to absorb it from your methylene chloride layer? So what I did was I put some in a test tube for you so that you can see kind of how it flows. It's pretty, and it flows like sand. Okay, it does not clump. You can see it kind of just bouncing around, just free flowing. When it's in the liquid, I call that snow globing, because when you give it a little shake like that, it can be swirling around and just kind of flowing, free-flowing particles, like individual granules, as it is in here. So what you want to do is you want to take a close look at this in real life and see if you have any small particles like this that remain in your methylene chloride, okay? So we're going to go ahead and pour that in there. Now, the amount that you initially want to go with is just the end of a pipette, or I'm sorry, the end of a spatula. Scoop it in there, and then you're going to want to, you see how we have some stuff stuck to the walls? Well, that's not free-flowing, right? It's stuck to the walls. And same thing, when I kind of move this around, it's not kind of flowing around as much as we would like. Or it's not bad necessarily. What this means is when it gets all clumpy like that, is not free flowing, that means that it absorbed water. Where did it absorb the water from? Well, it absorbed it from this solution right here because there was methylene chloride and water mixed together, right? Or at least in the same container. And so upon our transfer of methylene chloride in the extraction of caffeine, we transferred a little bit of water each time we touched that solution with the pipette, right? And so we want to get rid of all that water because we don't want it in there. And the way we're doing that is with this anhydrous sodium sulfate. The sodium sulfate will absorb water and get clumpy. And that's exactly what we see here, right? So what we want to happen eventually is that sodium sulfate to not be clumpy anymore, because that means that it absorbed all the water, and then now we introduce a little bit more, and then it has nothing to absorb, so it's just free flowing again, right? Just free flowing, just like it did in this jar when there was no water present. Okay, so now what we're going to do is we're going to add a little bit more. And again, just the tip of a pipette, why do I keep saying that? Just the tip of a spatula. Okay, so I did that. I just put it in here just for fun. So now we can kind of give this a little swirl. So you can see the stuff is moving around now, right? You can see it bouncing, bouncing. So these, it might be difficult to see in the video, but we've got some individual particles moving around, but we've also got some clumps moving around. And so that's good. It's doing its job. It's absorbing the water. And it might be done. What I'm going to do is let that hang out for a minute or two. And then I might add a little bit more to see how that responds. And we'll go from there, okay? So, to be continued. All right, so I added a little bit more just because you know how to pour things, right? And I like the way it's looking now. It's kind of difficult to see in the video, but we can see some clumps chilling right like on top, right? But other than that, right below it, because the bigger stuff's going to come to the top, the small stuff's going to go to the bottom, right? And so down below, we see some individual particles just kind of tumbling around as I'm spinning this with two hands carefully. And also I'm tilting it at an angle such that this liquid is not going to fall out, okay? So tilting it at an angle that's appropriate, and then I'm also twisting, and you can see it tumbling. And so that's really what I want. And so I'm going to let that hang out. What we need to do now is transfer the methylene chloride to a pre-weighed 10 ml Erlenmeyer flask. So let's go ahead and weigh that Erlenmeyer flask out. All right, as I roll up to the scale, we got a mass on there, or negative mass. So I'm going to zero that out or tear it. I'm going to place this cute little 10 milliliter Erlenmeyer flask that is nice and clean right on there. We're going to close all the doors. We need some privacy for this guy while he gets weighed. And we're going to record that mass of the Erlenmeyer flask before the addition of the the addition of methylene chloride with the caffeine. And so it's 14.781 grams. Okay, so go ahead and record that. This is the before mass, and then we're going to get an after mass later. All right, so we've got the pre-weighed Erlenmeyer flask ready to go. Boom. And we've also got our methylene chloride layer drying here. And I really only put in about 2 spatulas full of the sodium sulfate drying agent. And after that, like a tiny bit, little tester to see if it's tumbling, if it's snow globing. And so I'm not going to need to worry about anything getting left behind or stuck inside of here. But if I added maybe 3 or 4 spatulafuls of sodium sulfate, I would consider transferring all of this liquid and then leaving behind the sodium sulfate. And once I leave the sodium sulfate behind, I might rinse that with a little bit of methylene chloride and then transfer it again. And that's just in case I get anything important left in that sodium sulfate. Okay, I'm not going to do that. I'm letting you know if you put a significant amount of sodium sulfate, meaning 3 to 4 spatulas full, then you might want to consider rinsing it. Okay. That being said, if there's any loss of product, maybe that's where it went. Who knows? Keep that in mind. And these are the things that you want to kind of think about as you're doing this work. Because if you don't get 100% yield, which never do ever, where did it go, right? It had to go somewhere, right? Conservation of mass has to still be there, right? So that's one possible thing, right? Next thing, pipette. This is that yucky pipette, eh? Do you guys know what that is? Did you figure it out? It's caffeine, right? So as methylene chloride drips, we squeeze that out into here. And then some of it's left behind though, right? And as it evaporates, because it's got a high vapor pressure, that caffeine that was dissolved inside of the methylene chloride doesn't evaporate also, so it just gets left behind as a white residue inside of that pipette tip or pipette inside, and so that's caffeine. So that's something to keep an eye on when you're working with things. If you start seeing like a residue buildup, think about what it's from, because it might be important, it might be dangerous, it could, there's a variety of things that could be worth thinking about when that happens. So holding these 2 things. Now, when we're transferring the methylene chloride, it's really important that we're careful and we do not. So wait, sorry, I need to focus for a second. Dripping pretty fast, so I got to be fast in when I choose to move that into the Erlenmeyer flask. So I typically wait for a drop and then go right after that after I've timed how quickly those drops are dripping, okay? So what I was saying is that it's really important to leave the solid material behind, okay? Because we don't want that to be calculated in our mass of caffeine that we've extracted. So if it's necessary, we can technically filter it, but right now I think we can be really careful and not take any sodium sulfate. Oh, look at that. Bummer. Look at all that sodium sulfate I got. Whoopsie daisy. So that's going to happen. And so what I want to do is show you how to set up something called a pipette filter. Okay? So let's check it out. So what we've got here, check it out, a pipette. Hey, look at this, a little cotton. So what we want to do is place that inside of the top, just a little bit. It's kind of, I'll give you a reference point. So it's really thin, right? And then the height of it is, I mean, it's the size of the tip or this little portion right here that's kind of segmented, kind of like a worm. You don't want too much, but you want just enough to plug the pipette as you push it down with another pipette, and then you gently tap. Don't push too hard. And so it gets plugged in the thinner portion at the bottom, okay? So now what I can do is place this pipette filter inside of my Erlenmeyer flask, right? And I've got my sodium sulfate methylene chloride solution here, and you can see that solid material on the wall of that right next to the E on my shirt. That is the sodium sulfate, and that's what I didn't want to go inside of my Erlenmeyer flask because that would add to the mass of the so-called caffeine that I extracted. But by putting that cotton in this pipette, what I've done is created a filter, and it does not allow anything but the solution, the methylene chloride caffeine solution, to make its way through, and now I don't have to be very careful. So super awesome, very useful, very easy to make too, right? It is important. Like it'll take some practice to figure out like how much cotton to put in there, but you'll get that pretty quick. One thing I also want to show you is, you see this pipette? You can actually see a little bit of liquid left in there still, right? So what I'm going to do is place the bulb on top very carefully so as not to break anything. And I'll lift it up for you to see. It already kind of started coming down, but if I squeeze the bulb, you can see some stuff dripping out. One thing that's going to be really important in the future, on future labs and preparation of these types of things, is don't let go of the bulb. See, my fingers are still pinched here. Do not let go of those until you've popped off the bulb, and now I can let go, okay? So the reason why I say that is because if you were to let go of it like this, it's going to suck air through, and then that filter there is going to fly up, potentially move around, and then if you were going to add more liquid to it, it now has an opening because it came up and moved, and now some of that solid material can make its way down, and we've just ruined our filtration process. And so that's just something to think about in the future. Thought I'd introduce it. The more we introduce it, the more likely it's going to stick, right? So long story short, methylene chloride as well as caffeine in our Erlenmeyer flask. So now what we want to do is go ahead and place that inside of our water bath that we've already started heating. So it's probably to the right temperature because methylene chloride's boiling point is like almost room temperature. It's like 39 degrees Celsius, slightly above body temperature, which is crazy, right? Body temperature is 37 degrees Celsius. I think it's 39 degrees Celsius. And so just give it a hug and it's going to be starting to boil, right? So that's why it's really important to be careful with methylene chloride. Anytime you have something with methylene chloride in it, you want to make sure that if it's sitting there for any appreciable amount of time, you want to have something covering it. And so you're going to want to have maybe foil, or if it's very briefly, then you can put something called parafilm on it. And so, but we're moving right over to the bath right now, and so I don't need anything. So let's check it out. All right, so there's our water bath. I went ahead and put a little ring stand behind it with a clamp or a little clasp, and now I've clamped my Erlenmeyer flask very tightly with a 3-prong clamp. Okay, now I'm going to place this inside of here, and then we can lower it in. reason why this is important is because we don't want that methylene chloride solution just sitting in the water bath, or we also don't want to leave it unattended because it could start boiling out of control. It could boil over. And so we want to just be really careful as we're heating it. Keep an eye on it. We could even, if you don't want to clamp it like that, what we could do is take it out and just hold it in there and just be patient. Never just set it in there. I'm going to do it just for a brief moment. Oh, I can't because it's going to be too hot. You see it kind of bubbling? We don't want it to bubble out of control because then it could bubble over and we'll lose some of our compound, our caffeine. But if you leave it in there unattended and walk away, it could get tipped over and you'll get water inside, and then that just ruins everything. This took forever, and you got to start over. If there's no time to start over, then you just take an L on that. You take a 0 maybe, and so be patient. That's the key to a lot of chemistry. It really teaches us patience because we want. You also, if you've been working very slowly, methodically for like 3 hours, and then you're like, oh man, I want to get out of here, and you only have like 20 minutes left, don't rush that 20 minutes because that's usually when things are going to get messed up, and you're going to be really mad at yourself because you rushed, and even though you were really patient for 3 hours, just make sure you're patient the whole time, and you'll get it done, and you'll be happier in the end. And so I'm moving it so as kind of stir it so that way it doesn't boil over and we won't have any disasters. So you don't really want to watch me do this for a while, but so I'm going to turn the video off and we'll meet back once we get that solid caffeine left behind. And one thing we want to note is we just do not want to overheat it. So once we get that solid material visible, we're going to take a look at it and be kind of careful as to when to stop. Make sure all the liquid is gone, but also not heat the solid too much. Okay. So I got a nice white solid here, right? That just appears out of nowhere very quickly because methylene chloride likes to leave very quickly. But what I want to do is just for good measure, put it in here for another few seconds, and just to make sure that we've got all our methylene chloride gone. And then what we're going to do is make sure we dry this really well and go weigh it and see how much the flask plus the caffeine weighs. And then we can find the difference between the flask plus the caffeine and just the flask. And that will give us the mass of the caffeine that we extracted from the original 0.08. All right, so let's check it out. I'll dry it off real quick. All right, so I dried that really well. We've got the scale all zeroed out for us. So now, boom. See how much it weighs. 14.850 grams. All right, so record that. Now you want to find the difference between that mass as well as the original mass of just the flask, and that should tell you the amount of caffeine that we extracted. All right. All right, so that was the first part, which was the extraction of caffeine, right? So pretty cool. Do those calculations, and you want to compare the experimentally determined weight to the amount of caffeine that you calculated in the pre-lab calculation based off of the known distribution coefficient of caffeine and between water and methylene chloride. So now part 2 is the determination of a distribution coefficient. So what we're going to be doing is kind of calculating the distribution coefficient. So we can pick a variety of substances, benzoic acid, succinic acid, as well as sodium benzoate. So before we get started on this, we're going to need another wardrobe change. Okay, so